Conduction, convection, and radiation. Conduction is when two objects touch each other. For instance, this grilled cheese sandwich is touching the frying pan, and so energy is transferred from the metal pan into the food that you're cooking because it's touching. Hot pizza burning the top of your mouth when it touches, walking on hot sand when it touches. And what's happening is, remember, temperature is jiggling atoms inside an object. If I had a cup of hot coffee here, let me draw a little cup here, and if you had hot coffee inside of it, put a little handle on there, the atoms in the coffee are jiggling really fast because they are very hot. Where the atoms in the coffee cup, before you poured it in there, were room temperature. So they're still jiggling because they're not at absolute zero, but they're not jiggling as fast as the atoms in the coffee cup. But what happens is the atoms in the coffee cup bang into the side of the coffee cup and then make the atoms in the coffee cup jiggle a little faster. And then that's what you call an increase in temperature, because again, temperature is simply how fast are the atoms jiggling in the coffee cup. So it's the jiggling atoms inside the hot coffee touching the coffee cup and banging into it that makes the coffee cup get hotter, and that's what we call conduction. When the one is touching the other and the molecules are hitting against each other, the hotter one is hitting against the colder object and making them heat up as well. Convection is what we see in the middle one here. Now convection is the transfer of energy in fluids, either liquids or gases. They both flow. Okay. Conduction is with solid objects. Convection is fluids. And what happens is when you heat up something, well, hot things rise. It's like a lava lamp. Here at the bottom, when you heat them up, they expand. Hot things expand, and they become less dense when they move further apart, and those less dense materials rise up in the system. And then they'll get to an area where they can't go any higher, and I've got more stuff coming up, so it's got to get out of the way, so it spreads out along the top, and it will release that heat energy along the top. So you've transferred that energy from the bottom of the system up to the top of the system where it's being released out. And then as it cools down, the opposite happens. Hot things expand, but cold things contract, so they get closer together and more compact and dense. And the denser material then sinks down to the bottom. And then again, I got more stuff sinking over top of it, so it's got to get out of the way, so it flows back towards the middle and just repeats the process. These are called convection currents right here. They're just cycles through, and it carries the material up and down. It's like a lava lamp. The light bulb in a lava lamp is at the bottom, and the material expands when it gets hot. The little wax rises to the top of the lava lamp, and it will stay there till it cools off and releases that heat energy at the top of the lava lamp, and then it'll contract and sink back down to the bottom, and it'll just start the process all over again. So you got conduction is solids, convection is with liquids, and then radiation is what occurs in outer space. Light is the energy that radiates. Okay. Energy from the sun is radiation, and by radiation basically means it goes equally out in all directions. If you're standing around a campfire, it's radiating heat and light energy, but it's not just hot on one side of the campfire. It's hot behind the campfire and on top of the campfire and everywhere else, because that energy is going equally out in all directions. Strictly speaking, that's what radiation is. With campfires, there's something else to. I'll talk about this with my students. I'll just talk about it real quickly here. If you have a campfire, here's my little campfire burning. It's actually hotter over top of the campfire than it is on the sides. And the reason why that is you have radiation going equally out in all directions, and so that is equal amount of heating. But in addition, what you have on top of the campfire is the air inside here is being heated, and you have convection of the gas as it rises. So you're getting like a double dose of energy over top of the campfire. So that's why you always want to heat your food over top and not off to the side, because you're getting radiation, but you're also getting air rising. All right. So remember, convection is going to be a fluid, but a fluid is not just liquid. It's a gas also. They both flow. If you've got a fan on, then that air flows across the room. And that's how convection goes. Hot stuff rises and cold stuff sinks.